Hello students, today we are going to learn about preparation of alkanes. What are the different methods of preparation of alkanes? Alkanes are saturated compounds with the formula CnH2n plus 2. It can be prepared starting from unsaturated compounds like alkenes. What is the way out? We'll just check. The method is known as hydrogenation reaction. When alkenes or alkynes are subjected to hydrogenation reaction, you find it will result in the corresponding alkane. For example, if ethene is taken, what is ethene? It is C2H4. It has the formula CH2 double bond CH2. When this is subjected to hydrogenation reaction, what is hydrogenation? Hydrogen gas in the presence of catalysts like platinum or palladium or nickel in the presence of heat. You find that the double bond in the compound breaks because we have the pi bonds in between. The pi bonds are weak. It can be broken easily. So you can think of the pi bond being broken and two hydrogens entering on either side, resulting in the corresponding alkane with the formula CH3 single bond CH3. The same happens with ethyne also. What is ethyne? Ethyne has the formula C triple bond C with 2H on either side. So this is ethyne, which is commonly known as acetylene. When it is subjected to hydrogenation, the same reaction happens. It happens in the presence of platinum, palladium or nickel. If you are using nickel as the catalyst, we have to heat the compound. Otherwise, you find that the products are not formed. So you find that when hydrogenation occurs at a time, the pi bond break and it will result in the corresponding alkene. So it forms CH2 double bond CH2, which on further reaction with hydrogen in the presence of these catalysts, either platinum or palladium or nickel in the presence of heat, you find the double bond again breaks, resulting in the formation of CH3 single bond CH3. This reaction we call it as hydrogenation reaction. You find that hydrogenation reaction, if it happens in the presence of nickel at a higher temperature, the reaction is specifically known as Sabatier-Senderen's reaction. This is one method of preparation of alkane. But this method is not suitable for preparation of methane because unsaturated compounds contain at least 2 carbon atoms. The second method of preparation of alkanes, it is starting from alkyl halides. This is the common name and it has the formula Rx, where R stands for CnH2n plus 1 and X stands for halogens such as fluorine, chlorine, bromine and iodine. But in this reaction, starting from alkyl halide, we better start with chlorine, bromine or iodine. So except for fluorides, this method is suitable. Alkyl halide, when it is undergoing reduction in the presence of zinc and hydrochloric acid, you find that it produces nascent hydrogen and that will result in the formation of the corresponding alkane with the removal of hydrogen halide. You can think of the reaction happening as Rx plus HH. Together, there is the elimination of hydrogen halide resulting in the corresponding alkane and HX. Suppose if you have taken chloromethane, when it reacts with zinc and HCl, it produces nascent hydrogen and it results in the formation of methane and hydrogen chloride. Starting from alkyl halide, we can also prepare the higher alkanes. For example, if I take Rx and treat it with sodium metal in the presence of dry ether as the solvent, you find that it will react in such a manner that the higher alkane is produced, for which two alkyl halides are required and two sodium atoms are required, and you find that the reaction will result in the elimination of sodium halide and the higher alkane RR is obtained. So to make it specific, we'll take the example of methyl iodide. What is methyl iodide? Methyl is CH3 and iodine is I. So CH3I is methyl iodide, which is otherwise known as iodomethane. Iodomethane, when it reacts with sodium metal in the presence of dry ether, what do you get? We'll just find out. So ethyl bromide plus another molecule of ethyl bromide, it is reacting with sodium to form sodium iodide along with ethane. So you get CH3 single bond CH3 along with sodium iodide. So we started with one carbon atom. So this is haloalkane, specifically known as iodomethane. And what do we get? We get ethane as the product. So we started with one carbon atom and we are getting two carbon atoms. So this is a sort of stepping up reaction. The reaction between alkyl halide in the presence of sodium metal in dry ether to form the higher alkane. This was first experimented by Woods, and this reaction, it is known as Woods reaction. So Woods reaction helps in preparing the higher alkanes. The limitation of Woods reaction is that we cannot prepare methane using the process. This reaction is answered mainly by chlorocompounds, bromocompounds and iodo compounds. Here, the net reaction involves the formation of symmetrical alkane. That means it produces even number of carbon atoms in the product. Now the question is, how will you prepare methane? So for that, the third method is used. The third method is known as decarboxylation reaction. So how is decarboxylation reaction, that is removal of carbon dioxide, happening? So when the sodium salt of carboxylic acid is treated with soda lime, we get the lower alkane. What is carboxylic acid? You know carboxylic acid has the formula RCOOH. When it is treated with sodium hydroxide, we get the sodium salt here. How is the reaction proceeding? H of the acid reacts with OH of the base and it results in RCOONA plus H2O. What is this RCOONA, which is known as sodium carboxylate? So suppose we have taken CH3COOH. What is the name of this compound? This compound is named as ethanoic acid. This ethanoic acid, when treated with sodium hydroxide, we get the sodium salt of ethanoic acid, which is known as sodium ethanoate. Here, H of the acid reacts with OH of the base, resulting in the removal of water. So then we get CH3COONA along with water. This sodium ethanoate, when it is treated with soda lime. Now the question is, what is soda lime? Soda lime is a mixture of caustic soda and quicklime. What is caustic soda? It is sodium hydroxide, and quicklime is calcium oxide. So the mixture of sodium hydroxide and calcium oxide, commonly known as soda lime, when it is used and it is heated along with sodium acetate or sodium ethanoate, we get the lower alkane. So what is happening there? There occurs the decarboxylation reaction. So you can think of the reaction happening like this. H of sodium hydroxide is combining with CH3, resulting in the formation of CH4 plus. It gives Na2CO3. So this reaction, we call it as decarboxylation reaction, because carbon dioxide is removed as sodium carbonate in the process, and this is affected by treating it with soda lime. So soda lime is a mixture of quicklime and caustic soda. So together the reagent is known as soda lime. So when decarboxylation of sodium ethanoate happens, we get the lower alkane. So we started with 2 carbon atoms here, and in the product we are getting only 1 carbon atom. So this is a sort of stepping down process. What do you understand by decarboxylation? Decarboxylation reaction is a chemical reaction which results in the elimination of carbon dioxide, and this is affected when you are heating the sodium salt of carboxylic acid with soda lime. So you find that when sodium ethanoate is heated with soda lime, it results in methane along with sodium carbonate.